Hi guys, so this is our video on chapter 6.6 Moments and Centers of Mass. The whole chapter basically revolves around finding the center of mass by plotting it on the x and y axis. The whole chapter revolves around these two main formulas, x bar being the x coordinate of the center of mass of the object, and y bar being the y coordinate of the center of mass of the object. We'll show you how to use these formulas in an example. So this is our example. In this case, the equation of this line here is y equals to 2x. And the limit is from 0 to 1 on the x-axis. And we need to use this formula to solve. So x bar is equal to my over n. My is equal to integration of x curly dn. So obviously we need to find x curly and y curly. Step 1. X curly and y curly. We have to take first a small strip. We'll take the x part of this as x curly and the y-axis part of it as y curly. Therefore, we have x curly is equal to x. Y curly, as a general guideline, is equal to fx plus gx over 2. So fx being y equals to 2x, and gx being non-existent, we take it as 0. 2x plus 0, which is 2x. 2x divided by 2, we get x. So x curly is x, and y curly is also x. In step 2, we have to find the area, dA. dA will be given as fx minus gx. Again, fx is y equals to 2x, and gx being non-existent is again 0. 2x minus 0 will be 2x, will give us the final answer 2x dx. Step 3, finding the mass of the object, dm. dm will be equal to density of the object multiplied by dA. So again, dA was fx minus gx. So we sum in d, our value from dA back in here, and we get the density 3 multiplied by dA will give us 3 times 2x dx, which will bring us to 6x dx as our final answer for dm. And therefore we'll be able to sum in all these values, and we'll be able to get my is equal to x curly, which is x, dn, which is 6x dx. And to get n here, we'll need to integrate dn. So continuing on, we use x bar is equal to my over n. My is equal to integration from the limit 0 to 1, because we have x from the x-axis here, 0 and 1. So our limit is 0 to 1. Integration 0 to 1, x curly dn. Subbing in those values, we'll get x curly is equal to x, dn is equal to 6x dx. So when we simplify that, we get integration 6x squared dx. When we integrate it, we'll get 2x cubed. And when we sub in the limit, we'll get our final answer as 2 for my. Now next we need to find n. And as I explained earlier, n is equal to the integration of dn from the limit 0 to 1. So when we sub in that, dn is equal to integration 6x dx. And when we integrate that, we'll get 3x squared. Subbing in the limit 1, we'll get 3 as our final answer. So using this formula, x bar is equal to my over n, we get my, which is 2, over n, which is 3, is equal to 2 over 3. And that's our final answer for x bar. Now for the case of y bar, y is equal to mx over n. Mx will be equal to integration of y curly dn. In this case, our y curly just happens to be the same as our x curly. They're both x. So doing the exact same thing, we get our final answer to be 2 as well. So mx and my both happen to be 2. So we get our y bar also as 2 over 3. Since so our x bar is equal to 2 over 3 and y bar is equal to 2 over 3, our centroid will be 2 over 3, comma 2 over 3. So the second part of the chapter explains how we find the center of mass using a technique, using the Pappus theorem. which basically involves using this formula. Volume is equal to 2 pi phi a, where phi is the distance from the axis in which you're revolving the object around to the center of mass of the object. In other words, it's x bar or y bar, depending on which axis you revolve around.
In this example, the question find the center of the triangle by using the Pepper's theorem, given the volume 1/3 pi r square h. In this question, we assume that r is equals to a and h is equals to b. First, we need to find the area of the triangle by using the triangle formula, which is a equals to 1/2 times a and times b, which will give us the answer 1/2 ab. The next step is to find the x bar by using by equals to 2 pi x bar a. We will equate by to this formula, which will give us 1/3 pi a square b equals to 2 pi x bar 1/2 ab. By cancelling off the 2, which will give us x bar equals to 1/3 pi a square b over pi ab. Therefore, by simplifying this, we will get the answer x bar equals to a/3. Next, we need to find the y bar for this question. To find the y bar, we will use Vx equals to 2 pi y bar a. By using the same exact method, we will get 1/3 pi b square a equals to 2 pi y bar times the area, which is 1/2 ab. Bringing the y bar over, we will get 1/3 pi ab square over pi ab. By simplifying, we will get our final answer y bar equals to b/3.